Hi.
Hold on. Hi, geometry students. It's me again. This is my son, Drew. I just thought I'd bring someone else in to say at least hi, because you guys probably get bored just looking at me. So, Drew, do you want to say anything to the geometry students? You want to tell them how old you are? No? You want to tell them anything? Do you like math? Yeah. So, uh, do you want to stick around while we go through this stuff and try and learn something new? You sure? You can stay here. All right. If you need to go, you can go, but otherwise, you can listen. All right, guys. So thanks for doing the discussion posts. I read through all those. That was really helpful. I'm going to have you do it again at the end of this next week. I got a good feeling. Pretty much everyone said almost the same thing. It's nice to be at home because I get to sleep in, but I miss being with my friends. Trigonometry introduction is going pretty well. I understand the basics, but I'm confused on square roots. It was amazing. Almost everyone said the same thing, so I got a good feeling of what I should maybe talk about. So I'm going to talk just a little bit about square roots, give a quick overview of incorporated with that will come out the basics of trigonometry that you should know at this point. And then I do want to start talking a little bit about special right triangles, which I realized was one of the IXL things, or I shouldn't say, it came up in R.8 when they were looking for side lengths. They were asking you to give exact values of side lengths. They weren't taking the decimal values in certain problems. Those are what we call special right triangles, and those types of problems. And again, I wasn't prepared that IXL. I wish they would have those in a separate section, but they don't. So I know it was kind of difficult. So I want to address that a little bit. We'll talk about that more later in the week. So anyways, here we go. So first off, on IXL R.1, towards the end, they were giving you triangles with radicals in them. All right, and that was confusing many of you. So let me just go through two examples that would use this triangle right here and see if that can help you forward a little bit. So let me get positioned a little bit better. And here we go. So I think on this one they asked you, what is the tangent of E? Right, so you focus on the angle. There's E, and then you look at the definition of tangent, which is always the opposite side over the adjacent side. So the opposite side here is going to be 3 square root 3. And then the adjacent side is going to be this side here, the 3 square root 5. Okay. Now, that's essentially your ratio. But IXL was really picky about how they wanted it put in. They wanted it simplified. Right? So a couple things that involve simplifying here. You can cross out the 3's. Anything outside of the radical that's being multiplied can just cancel out like that. So now you're left with square root 3 over square root 5. And then one of the things we talked about a little bit in the last video was this idea of rationalizing the denominator. You can't leave a square root in the denominator. So we take square root 3 over square root 5, and you're going to multiply by a fraction that's equal to 1 using that denominator number on the top and on the bottom. Okay, so that right there is what you need to multiply by. When you multiply across the square root 5 times square root 5, the square roots essentially go away. Basically what that would give you, it would give you the square root of 25, but then we know the square root of 25 is 5. So I'm going to take that out and just put 5 there. And then square root 3 times square root of 5, so we can just take the 3 and the 5 and multiply them together and get square root of 15. So square root of 15 over 5 is the way they are going to want that one written. So I'm going to leave that there right now, and I'm going to do a different one. I'm going to come back to that problem here. But for now, let's just do a quick recap of simplifying radicals. Can you put that cap on, please? Thanks. Right, so I just want to talk a little bit about simplifying radicals. This is the part that in hindsight, I wish I maybe would have done right away for you guys, just so you would have had some indication of how to do these going forward. So I want to show you just a couple. First of all, the rule is this: if you have a product of two numbers under a square root, that is equal to the product of both of their radicals separately. Okay, so that's the rule. Now, using that rule, if we had something like the square root of 50, if we were going to simplify the square root of 50, what we would do is we would take and we would write 50, we would break it down into two of its factors. Okay, remember, factors are numbers that multiply together to give you a number. Okay, so there's lots of factors that we could choose. We could choose 2 and 25, we could choose 5 and 10, 1 and 50, but really there's a best set to choose from. And we always want to choose from our list of perfect squares. 25, 36. Okay, so if we think of all our perfect squares, 2 squared, 3 squared, 4 squared, 5 squared, 6 squared, etc., which of these numbers go evenly into 50? Well, 25 does. And it's 25 times 2. Both of them don't have to come from the list. Just one of them, just this one here. And so then once you do that, then this rule up here says you can give each one of those factors its own square root. And then you can take and say, well, hey, I know what the square root of 25 is. It's 5. And square root of 2, I don't know what that is. That just stays square root of 2. That's your answer. Okay, I'll give you one more here. How about the square root of 92? Okay. Well, which one of these go into 92 evenly? Well, it might be hard to know that. You might have to take your calculator and kind of check through some. It would come out to be 4 and, what was it, 4 and 20, just did this, 4 and 46. 4 and 23. Is that right, Drew? He's shaking his head. Okay, good job checking me. All right, so you got square root of 4, square root of 23, and then you take, and we know the square root of 4 becomes 2. And square root of 23 stays the same. There you have it, okay? Now, I'm going to give you another one, and I want you to, well, let me show you one more quick. What if we had this? Square root of 64. Well, don't be fooled. Remember your perfect squares. If it comes out nice, just take it. You don't have to go through that process. But if it doesn't come out nice, go through that process. This is what I want you guys to try quick. I want you to try the square root of 18. Pause the video right now. See if you can work that one out by yourself, and then unpause it. All right, so hopefully you just work this out. Square root 9 times 2, so you get 3 square root of 2. Okay. So that's a quick just run through of how to simplify radicals. I believe you guys have technically seen this a little bit in Algebra 1, but here it is again. All right, back to this. One more here. So what if we did the cosine of g? All right, so here's our g. The cosine in this case is adjacent over hypotenuse. So the adjacent side here would be 3 square root 3. The hypotenuse is across from your right angle is 6 square root of 2. Okay. Now, at this point, the 3 can go into the 6 twice. So we can initially just say this is square root 3 over 2 square root 2. But IXL is not going to like having the square root in the denominator. So we're going to try and rationalize this. And when you do this, you don't multiply by the whole denominator, you just multiply by whatever the radical is. So in this case, square root 2 over square root 2. Square root of 3 times square root of 2 is square root of 6. And on the bottom, this 2 just comes along for the ride. And then square root of 2 times square root of 2 is another 2. So you got to multiply those together and you get square root 6 over 4. Okay. So I think I'm going to stop there. I was going to talk a little bit about special right triangles because I think it was R.8 where you guys had problems like this, and they wanted you to find UV, and they wanted the exact value. And it involves understanding, basically memorizing what we call a special right triangle, okay? And we're going to memorize ratios of these special right triangles that we can then apply to these. Because if you notice, these two triangles are similar. We've talked a lot about that. They have the same angles, all right? These would be similar by the angle similarity theorem. And so we would be able to make the sides, or we should say the sides are proportional, so we could set up a proportion with these two sides and then solve for the missing one, okay, keeping exact values. That, like I said, I'm a little reluctant to get into that too much because we're not together, and I know that that's a little harder, so we'll kind of see how that goes. Maybe later in the week I'll talk to you a little bit about that. But that's all for now. So thanks, everyone. Drew, do you want to say anything?
Bye.
See you later.